if you're watching this video, you're probably either lost with radicals or forgot from last year in Algebra 1. So I'm going to do basically what the paper says. It's going to be a very quick radical review. Front side only here. Show you the two properties that are needed really to simplify expressions. So the first property says if I have a number that has two factors, a and b can just be two numbers that are being multiplied together to give me another number, I can split this up into a radical of both factors. And this will make more sense once I get to actual numbers down here. The second property says if I have the square root of a squared, the squared and square root cancel and I'm left with just a. Notice no radical anymore. Okay? So, how do these properties apply down here? Well, 48 I could write as two factors, 8 times 6, right? So I could do the square root of 8 and I could do the square root of 6. I could break them up into two separate radicals. Those two numbers, those two specific numbers, aren't going to help me much here, but a different combination of numbers might. And that's what we're going to do. We're going to break down using prime factors. Now this is the way I taught it, and a lot of teachers do teach it this way. Some don't. So if you learned it another way and you'd like to hear that other way because it made more sense, ask me and I can go through that for you. All right, but I'm going to do it the way I've taught it, prime factors. So two numbers that multiply to give me 48. We'll just use 8 and 6. Neither one of those is prime though. So I'm going to keep going on both of them. So 8 breaks down into 4 and 2. Are either of those two numbers prime? Well, 2 is. 4 is not. I'm going to keep going 4. 2 and 2. Those are both prime. 6 breaks down into 3 and 2, which are both prime. So now I've circled them, which means I'm at the end of a chain, kind of. I'm done with my prime factors. I don't have anything that's not circled at the end. So now I can rewrite 48 as a square root of those 5 numbers being multiplied together. So there's 4 2's being multiplied together and a 3. So I have 5 factors, and now I can split those up any way I want, is what this property says. So I'm going to split it up this way. Okay? And there is a reason for it, and I'm going to talk about it more later down here. But 2 times 2 is 4. I could write square root of 4, square root of 4, and square root of 3, but I'm going to write it as another way. 2 times 2 can be rewritten as 2 squared. That's what I want you to see. Two squared is now property number 2. It's a number squared and the square root of it. The square root and squared cancel, and I'm left with 2. Same thing here. Not here, though, because it's not being squared. So that one just stays as square root of 3. Now these are both without radicals. They're on the outside of the radical. And so 2 times 2 is 4, radical 3. And that's simplified. Good idea to do is to check your work. What I'm doing here is I'm going to type the original radical expression, 46, square root of 48, 6.93-ish. I'm going to write that down real quick. And now I'm going to clear it. I'm going to type that in. If I get the same number, I probably did it right. 6.93, we're good. Okay, square root of 150. Well, I know I can put 5 into that. How many times? Well, 150 divided by 5 is 30. And then 30 breaks down into 10 and 3. And then 10 breaks down into 5 and 2. Okay, so now I'm going to rewrite those. And I like to go in order, smallest to biggest, 2 times 3 times 5 times 5. And now I'm going to break it up. Watch how I break this up. Okay. Why didn't I put 2 here? 2 numbers here? Well, because there wasn't a second 2. Why didn't I put 2 numbers here? Well, there wasn't a second 3. I'm looking for 2 of the same number. Not necessarily 3 of the same number, but 2 of the same number. Why? Because now I can rewrite that as 5 squared. This one I can't, and this one I can't. So those just have to stay there. So square root of 5 squared that's 5. Now we don't usually write a number that's outside the radical. We write that usually in the front. So it's going to be 5. But there's two numbers left over under the radical. This property up here goes both ways. If I have two numbers, I can put them back together to make one radical. I have two numbers, I can put them back together to make one radical. 2 times 3, though, is just 6. So that's the number left under the radical. So 5 radical 6. Okay. Last one, I made this number really big because I want you to see that this prime factorization can work even with giant numbers like this. 567, I don't really know what goes into that, so I'm just going to start guessing. I'm going to say, I know 2 doesn't because it's odd. Let's start with 3. Well, it worked right away. So 3 and 189. 3 is prime. I'm guessing 189 is not, but let's see. Again, I'm going to start guessing. 2 does not because it's odd, so I'll start at 3 again. Hey, what do you know? It worked again. 3 and 63. Now I know 63 has two factors. I know those are 7 and 9. 7's prime. 9 breaks down into 3 and 3. So 1, 2, 3, 4 3's. And a 7. I'm going to break them up into pairs. And anything unpaired I'm going to put there at the end. So that's 3 squared. It's also 3 squared. So 3 squared is 3. Square root of 3 squared is 3. Oops, sorry, times. Square root of 3 squared is 3. Square root of 7, so this is going to be 9 radical 7. Okay? If you still need more, ask, but hopefully that helped you remember how to do radicals.